is the first video of at least 3 on counting. Now, the first video is going to cover 3 basic counting rules, one for multiplication, one for addition, and one for subtraction. So let's just jump right in. So the first one we're going to cover is called the product rule, which corresponds to multiplication. And each one of these are going to have like a keyword associated with them. And is the keyword that's going to tell you to multiply. So here is the product rule stated in words. So basically it says you start out with some event E that can happen in different ways. And then you have another event F that can happen M different ways. Under this fundamental assumption, the occurrence of E has no effect on F. As long as that's true, then the number of ways that E and F can occur is just the product of N times N. So it's called the product rule because you just multiply. Okay, so here's the kind of an idea. You think of the product rule whenever you see the word and. So let's just do a quick example. So a startup with 4 employees rents an office suite with 7 offices. How many ways are there to assign the employees? When I do problems like this, I like to put things into bins, okay, and kind of draw parentheses for each bin. So I have 7 different office suites. Excuse me. Yeah, there are 4 employees and 7 offices. So each employee is going to be assigned an office. So here's the first employee, the second employee, the third employee, and the fourth employee. So how many different choices does the first employee have for offices? Well, there are 7 choices, right, for the first employee. How many choices does the next employee have? Well, we don't want them to share offices. So the second employee has 6 choices. The third has 5 choices, and the next has four choices. And by the product rule, we're assigning the first and the second and the third and the fourth. So a bunch of ands. And so the product rule says we just multiply. That's why there are the parentheses. And so there are 840 different ways to assign the offices. Now, here is an example of implementing the product rule in Python. And this is one of those situations where it would be in your best interest to kind of go through this on your own and then open it in Python Tutor, pick some values for N1, N2, N3, N4, and N5, and just see what happens. Okay, so just go through it and try to understand how the code is working. Let's talk about this example. So suppose that there are, first of all, 27 computers in some computer center, and each computer has 15 different ports. How many different ways are there to choose a specific port? Well, think of it like this. First of all, you're choosing a computer. So this is going to be the number of ways to choose a computer, and you're going to choose a port on that computer. Well, 25 computers times 15 ports is going to give you 405 ways to choose a port. Now, as always, I encourage you to read through the textbook and pick up all the details that I'm leaving out. But here is an example video that you can watch. And this is actually me in the video. A little bit further down, you're going to see one with Dr. Kathy Penzon, who also helped write the textbook and teaches discrete math. We recorded these about a month or maybe a little bit less than a month before the pandemic got really bad. So that's why there are only a handful of videos that are structured like this in the textbook. The rest of them were made with tablets and iPads and things like that. But that's why this one looks different. So I encourage you to watch this video. It's just another example using the product rule. Moving on to the sum rule. The sum rule is means you just add, of course. Now, the key thing to look here is when you have XOR. When you have an exclusive OR, that's when you're going to use the sum rule. So the way it's stated, suppose you have event E and it can occur in different ways. event F, it can occur M different ways, but both events cannot occur at the same time. So that's where the XOR part comes in. So the number of ways that E or F can occur is equal to this sum. You're literally just adding them up, okay? So let's do an example. A student in a capstone course can choose a product from 3 different professors. The professors have 3, 7, and 4 different projects. So the first professor has 3 projects, the second professor has 7 projects, and the third professor has 4 projects. No project is on more than one professor's list. How many possible products can they choose? Well, the students can choose to work with Professor 1 or Professor 2 or Professor 3. And since there's no project that's on more than one list, you just add them up. So 3 plus 7 plus 4 equals 14. So here's one that you can try. If a card is drawn from a standard 52 card deck, how many ways can the card be even or a king? Well, it says you try, but I think I'm going to go ahead and work it out. All right. So the number of ways that we can have even or a king, well, this is going to be, cards can't be even or kings. Excuse me, even and kings at the same time. Even cards are going to be cards that are 2, 4, 6, 8, or 10. And the kings are going to be cards that are kings, right? Kings are face cards that they don't have like a parity. So I can't have a card that's both even and king. So by the sum rule, it's just the number of even plus the number of kings. Well, how many even cards are there? So there are 1, 2, 3, 4, 5 even cards for every suit. And there are 4 suits, so it's 4 times 5 even cards plus 4 kings, so they're going to be 24. All right. Now, when you go through the textbook, here is a video example made by Dr. Pinzon that's doing an example for the sum rule. Moving on to the subtraction rule. This is when you subtract. And it's a little bit of a misnomer. It's called the subtraction rule because subtraction is involved, but there's also addition involved too. And this is when you see or. So if your events are not mutually exclusive, that is, they can occur at the same time. So suppose event E can occur in different ways, event F can occur in different ways, and they can both occur P different ways. Then the number of ways that E or F can occur is this, okay? So the way you want to think about this is you have to subtract off the overlap. So let me draw a little picture here. This is going to represent the number of ways that E can occur. This is going to represent the number of ways F can occur. And then this overlap is going to be the number of ways that E and F can occur. So if I use yellow to shade in the number of ways E can occur, and I use green to shade in the number of ways F can occur, you can see that I have counted the overlap 2 different times. I've counted it once when I counted E. I've counted it a second time when I've counted F. That's why we have to subtract it off. Okay? So if you're counting the number of ways E or F can occur, E or F, it's going to be the yellow, which we said is going to be N, the number of ways E can occur, plus the number of ways F can occur. We decided to call that M. But look, I counted in yellow, I have the middle. So that's P counted once. And then P is counted again for the green. And so we don't want that to happen, right? We don't want to count it twice. So what we do is we have to subtract it off. So it's n, because that's counting p once, plus m, that's counting p once, and then subtract it off, and you've only counted it one time. All right, let's do an example. So a tech company receives 200 apps for a position. 150 were iTech majors, 43 business majors, and 25 were double majors in business and iTech. How many did not apply? Excuse me, how many of the applications did not major in iTech or in business? Well, what we need to figure out is how many of them did, okay? How many did major in iTech or business? So the number that are majored in iTech or business is going to be, notice that we have some that were double majors. So it's an or, but they can happen at the same time, so we have to subtract. So this is going to be the number of iTech plus the number of business minus the number of iTech and business. So how many iTech do we have? 150. Business majors, 43. Double majors, 25. So add, subtract. That's going to give you 168 that were iTech or business. And then there were 200 total applications. So 200 minus 168 will tell you the number that did not major in iTech or business. So that's how you do that one. Let's do this next one. This is about bit strings. Now, a bit string is just a string that consists of zeros or ones. So some examples of bit strings would be 0, 0, 0. These are bit strings of length 4. 1, 1, 1, 1, 1, 0, 0, 1, 1, 1, 0, 1. These are all bit strings of length 4. So what we want to count is how many bit strings of length 4 start with 1 or end with 00. Well, let's count it. What I'm going to do is I'm going to write the ones that start with a 1, like this, 1, and then I'm going to draw a star to represent, it can be whatever it wants. Okay, this is how many are going to start with 1, or excuse me, the ones that start with 1 are going to look like this. The ones that end with 0, 0 are going to be of the form star, star, 0, 0. And then the ones that are both are going to look like this. They start with a 1, there's a star, and then they end in 0, 0. Okay? Well, let's look at the first one. How many ways can they start with a 1? Well, the bit in the first position is already determined. It has to be a 1. The other 3 positions can be 0 or 1 for each one of them. So I have 2 choices for this position and 2 choices here and 2 choices here. So that's 2 to the third different ways to have a bit string of length 4 that starts with 1. For the ones that end with 00, I have 2 choices here and 2 choices here. So 2 squared. And I have 2 choices here. So 2. So the number that start with 1 or end with 00 or both is going to be 2 to the third plus 2 squared minus 2. In other words, it's going to be this. 8 plus 4 minus 2 gives you 10. All right? Now, this you try example is going to be basically very similar to this video, and I'll also talk some about a deck of cards there in case you're unfamiliar. So go ahead, and when you're reading through this part of the textbook, make sure you watch that video. All right, that's going to be the end. There's going to be another short video going up right after this one on the pigeonhole principle. But that's all I want to say about, well, not the end of the video, just the end of going through the book. I'm going to do some examples now. But that's what I wanted to say as far as the lecture stuff on the sum rule, the addition rule, and the subtraction rule. Now, in the notes, this is going to be a case where watch the videos, okay? Because there's lots more of examples. So, this is summing up the product rule, the sum rule, the subtraction rule, but please watch these videos that are embedded. Some of them are going to be the ones that are embedded in the book, but there are going to be some new ones in here too. and then try these examples. All right. I did pick a few examples that I did want to work on. So the first one is going to be, how many bit strings of length 8, excuse me, not bit strings in this case, how many strings of length 8 can be formed using the letters A, B, C, D, and E? And then how many strings have at least one E? Let's do the first part. So strings length 8 using these letters A, B, C, and D. Well, you know, I have 1, 2, 3, 4, 5, 6, 7, 8 different choices. Excuse me, 8 different slots to fill in, right? Because it's a string of length 8. And I have 5 choices for the first one, because I can pick A, B, C, D, and E. But I have 5 here, 5 here, 5 here, 5 here, 5 here, 5 here, 5 here. So in other words, I have 5 raised to the 8th power. The second part, we're saying how many strings have at least one E. So this at least one E, the number that have at least one E, I want you to notice this would be the same as the total number of strings minus the number that have no E. Because if I take the total number there are and I subtract off all of the strings that don't have any E's whatsoever, well, what's left over is going to be the number that have at least one E. Well, we already did the total. It's 5 to the 8th power. And then if I want to count how many of them don't have any E's whatsoever, well, that means I'm going to be looking at only A, B, C, and D. Okay. So that's going to be 5 raised, excuse me, not 5. It's going to be 4 raised to the power of 8. All right, moving on to the next example that I want to do. I'm not going to do all of these, just a couple to kind of let you see how these things work as usual. All right, how many strings of 8 uppercase English letters are there if, well, first of all, if letters can be repeated? Okay, so we're going to take a string of 8. So I'm going to draw this again. 1, 2, 3, 4, 5, 6, 7, 8. 8 uppercase English letters. Well, I have 26 choices for each one of them because there's 26 letters. So what is that going to be? 26 to the 8th power. What if no letter can be repeated? Well, that means I have 26 choices for the first one, 25 choices for the second one, so on and so forth. Okay, so I'll let you finish that one. What if it starts with X and letters can be repeated? Well, I'm going to have 8 of them again. But for the first one, I only have one choice. It has to be X. But the next one can be 26 choices, so on and so forth. And then D, kind of think about that one, okay? Remember, we're starting with an X and no letter can be repeated. The next example I want to do is talking about positive integers dividing into, positive integers less than 1,000, all right? So how many are divisible by 7? Well, the way you would count that is you would divide 1,000 divided by 7 and ignore the remainder. Okay, that's going to tell you how many numbers are divisible by 7. Okay, same thing for 11. That's how many to figure out how many are divisible by 11. You'll do 1,000 divided by 11. Now, to answer the rest of these, you need to be able to think about how many are divisible by 7 and 11. Well, 7 times 11 equals 77. And you need to notice something. These two numbers, they're both prime. So they have no factors in common. So to count how many are divisible by 7 and 11, you would do 1,000 divided by their product, which is 77. Okay. Now this only works because 7 and 11 don't have any factors in common. So you can figure out how many are divisible by both of them, multiply them together, and do 1,000 divided by 77. So this example is going to take some work unpacking what all the questions are asking. And, you're going to use the OR rule and thinking about what it means, neither one of them, and things like that. So, but this is enough, I think, to get you started. All right, this is all I wanted to say in this video. As I said before, there'll be another one going up at the same time talking about the pigeonhole principle.